What I'm going to do now is show you how to do some simple distance calculations, basically just Euclidean. What I want to do is I want to convert my cadastre file, this one here, to points. Now what I can't remember where it's hidden. I'm going to go feature to point. And there it is there. It's in data management. My input features is my cadastre. And my output features, I'll Google to it. In fact, I've done it already. But we will just pop him in there, go save. Yes. It's not going to let me because I already have a name, and then I go OK. And it creates a point thing. And that point is the BCGC cadastre point, which I have already created. If I open him up, let's just shut this, you will see it is just points. I can put it on the map. There's a lot of them. And what I can do there is I can go selection, select by attributes. I've done this already. You see I put in, let's clear, SA2 name equals, and I wanted Burley Heads. And it's found Burley Heads. I'll go Burley Heads. Selected all the points as Burley Heads, and what I can do there, just to make it easier, I'm going to go into selection, create layer from selected features. Now I've already done this and it's up there called Burley points, so we're not going to actually create a layer from that, and I'm going to turn this off because it takes too long to load. Now what we want to do is we want to find the direct distance between parks there and the cadastre points. But how do we do that? Because as you can see, the parks is not a linear feature. So there's a number of different ways you can do it. You can create random mesh of points, but there's also simpler ways. So for example, you could just use proxy. You could use Shelter as a proxy, or you could go into OpenStreetMap points. Let's have a look by attributes. We'll check on OpenStreetMap, if we can find it. There we go. Look at the F class. It helps to look at the attribute table. And what do we have here? Because hopefully we have something that they've already done for us. Our park. Beautiful. So if we go there, OpenStreetMap points doesn't seem to be, but the only problem is it's not showing in the same place. And that's the whole problem with ArcGIS, because quite often things will show is not necessarily where it is. So what we're going to do is, unfortunately, we're going to have to create a random mesh, which I will show you how to do now. What I wanted to do is to create random points in my parks, because a park is a polygon feature, but I need points. So I just clicked random points, and I clicked this. I've already done this, by the way. So click that as your location, call your feature class something like random points, and you want it in your recreation layer, one of your recreation layers. I popped in that one. Just ignore that, it's not going to work because I've already done it. You don't want 10 points for the park. I mean, you don't want 100 points, you want 10 points, and then you just go OK. And it creates a point file which it then adds to your map. So if I go into my table of content now, you'll see that there's points all over my map. And that's how you create random points, which you can work distance calculations. Just to reiterate, the important thing is to calculate the distance from one point to another point. And if you're trying to do it from cadastre, so there's cadastre there, if you're trying to do it from individual properties, and you're trying to calculate it to a park, it needs to be calculated from, so if you looked at this house, there's a little pocket park there. If you try to calculate from that house to that park, then this is a polygon feature, as is that. So what you need to do is put it into points, so you can do from point to point, because it's hard. You can't really calculate a distance from there to there, and we can show you. So from there to there is 1805 meters, whereas from there to there is 2009 meters, and from there to there is 2054 meters. So that's why we have converted them to points.